Hello, everyone. I'm Vishal Sharma. I'm also a senior data scientist at h2.ai. Let's start the hands-on session. But before that, I hope you were able to create your account on this platform, aquarium.h2.ai. So after you have created the account, then you can click on this link called for Browse Labs, and it will bring you to different labs which are available, where you can try hands-on for driverless AI or using H203, etc. But for this particular session, we'll use driverless AI version 1.9.3. So please click on this link, this lab, uh, after to start your session. Yeah. Yes, so this is what I was saying. So after you click on Browse Labs on the top left, then it will bring you to this screen. And in this screen, if you go to the bottom, you can find this lab, Driverless AI Training 1.9.3. So if you click here, then it will start. It will create an instance for your Driverless AI session. So here we want to use driverless AI via web. And so for that, we click on this link. If you go to the bottom, you click on the lab URL, and the lab URL is the driverless AI URL. So you click on this link, and it will start a driverless AI session for you. Yeah. Yes. This is the page for driverless AI. I hope all or most of you are able to reach this screen. If not, please feel free to ask some questions, like if you are facing any difficulty into reaching driverless AI. Yeah, but this is the page where you access driverless AI. So this is the page where you can see the different data sets. So driverless AI, as Shiva mentioned earlier, is the H2O AutoML platform, where you are given AI in a box, and we are able to create models and create experiments in an AutoML manner, be it like classification experiment or regression experiment or NLP time series, as well as computer vision experiments. So first of all, like you can download data sets. For this session, for driverless AI, you can download data set from like your file system, Hadoop file system, or you can upload from your local, or you can upload from S3. For this particular session, I have uploaded some data on S3. So where the URL, so let me flash the URL for that. So the S3 link for the dataset is this one, which I hope you have gotten in your chat as well. So this is the S3 link. S3 bucket link. So what you can do is you can click on Amazon S3, and you can paste that link that is provided to you, and it will show you the dataset that we have created for this particular session. So if you click on this, then and click import, then it's going to import the file for you. For me, I already have that file in my session, so it is telling me that it's already exists. Yes. So this is the file which I will use for this particular session. So to talk more about this particular data set and use case that we are going to work on. So this use case is XNLI use case, which is a natural language inference use case, where the idea is that if you have sentences or text from two different sources, then we need to predict whether these two sentences are talking about on the same thing, if their meaning is same. So if it is same, then it is the label is entailment. If those two sentences are talking about different things, then these two sentences are like contradicting each other, then the label is contradiction. And if these sentences are totally like not related to each other, and maybe they are talking about different things, then the label may be neutral. So our objective is to predict when we are given two sentences. The label is entailment, is contradiction, or neutral. So yeah, so we have gotten this data set, XNLI data set, um, which is a data set in 15 languages, including English, French, Spanish, Russian, Arabic, Thai, Chinese, and Hindi, etc. Yeah. So it's a mix of different languages, and as Shiva mentioned that we may be dealing with use cases where you are working with a mix of different languages. So this is a one particular example of that data set. And XNLI actually, and to be more specific, natural language inference is a very important use case, which is used in machine translation or for similarity detection or semantic search or information extraction in NLP, in modern NLP. And it's a fairly complicated task. So yeah, we'll try to solve that using the models that we have available in Travelers AI. Yeah. So again, I hope you are able to access this data set within your Travelers AI instance. Yeah. So after you have uploaded the data, then Travelers AI allows you to firstly like look at the details of the data set. So you can see what are the different like columns which are given in the data set and what are the different descriptive statistics of those columns. And you can also visualize them as in the table form. Yeah. So we have like the sentences in different languages such as French, Vietnamese, English, Russian, etc. So we have sentence one and sentence two, and they are in different genres as well, government, letters, telephone, conversation, etc. And our label is contradiction, or it can be entailment, or it can be neutral. So this is to visualize the data set. So within Travelers AI, you can also, after you have the data set, so for experiment and for simultaneous testing, you may divide the data set into the training set and test set. So let me show that again. So after you click on the data set and then you click on split, then it will allow you to divide the data set into train and test. So maybe let's try to create this split. We call it like XNLI train, and the test set, we call it XNLI test. And then we need to provide the target column. So if we are working with classification data, then we need to provide target column so that the split is done in a stratified manner. So here our target column is the gold label. So we click on that to create this split. Then you can define the split ratio also, which can be which you can define here as let's say 0.6 for the train data and 0.4, 40% is test data, 60% is the train data. And then you click save. Actually, let me rename it as yeah, so it has created the train data and the test data. So after you have created this train and test data sets, then you can start your experiment. And for that, what you need to do is you can again click on the data set. No need to right click. You can just simply click on the data set and click on predict. Yeah. So after you click predict, then it brings you to the experiment page of Travelers AI. So here you can see that the training data set is populated already. And what we can give some name to the experiment. For example, multilingual NLP. Yeah, so this is the name of our experiment, and it is telling me that this training set has 2K rows. And then what we can do for simultaneous testing, we can also bring in the test data set. So here I click on test, and my test data set is this one, which I created earlier. So I have populated the train data set and the test data set. Now I need to select the target column again to tell Travelers AI what is the target that we need to predict, and that is our goal label. So for now, we'll ignore this column, time column. So this is used when we are working with time series kind of problems. And we are not using validation data sets. Travelers AI will itself create validation data sets for like avoiding overfitting, etc. So it creates validation data sets in the most optimized manner. Then yeah, so after you have uh, specified the target column, then Traveler CI gives you three settings. One is accuracy setting, time setting, and interpretability setting. So these are some default settings that Traveler CI provides you. So I'll give an explanation of these later, but for now we need to start the experiment so that we can finish it earlier. And this is an NLP experiment, and we are using GPU models, so GPU-based models. So we don't have a lot of time to finish the experiment within this session. We need to launch the experiment, but yeah, before launching experiments, I want to tweak some settings. Um, so as Shivam, if you remember, Shivam had shared that for creating NLP experiments, you can actually use NLP models as transformers. Where you are using the embeddings from the NLP models as features, and which are going into further classification models. So we will use that particular NLP pipeline, and for that, what you need to do is you can click on expert settings, and after you have clicked on expert settings, then we need to find the particular setting which is responsible for creating the NLP transformer kind of pipeline. So these expert settings are for experienced data scientists, and these allow the experienced data scientists to tweak the experiment more, so that you are not relying on the default settings specified by Traveler CI. So here, since we want to specify that I want to use NLP transformer setting for creating a pipeline, so what I'll do is I'll click on NLP transformer. So ignore the warning here. And another thing is that, so this is the experiment settings that I want to select. Then I also want to, since we are working in multilingual data, within NLP, I can specify the models that I want to use. So if you click on NLP within the expert settings, and here you can look at these settings to where we can select the which pretend PyTorch NLP models we want to use. So here we can click here and see the different PyTorch models which are available for building this NLP transformer pipeline. So since we are working with multilingual data, so we can unselect the BERT-based and digital BERT-based models. We will keep the BERT-based multilingual model, and we will also select XLM Roberta model. So BERT-based model was created by Google, and then XLM Roberta created by Facebook, which used cross-lingual embeddings to improve the performance even further. Yeah, so we'll keep these two models in our pipeline, and then after that I'll click done. Yeah. There are two additional settings that I would like to do so that our experiment finish faster. So I will explain those later. But what you can do is you can, in this search space, yeah, you can click on Mojo. And you can, what you need to do is you need to switch off make Mojo scoring pipeline. And another thing I want to do in my setting is I want to stop creating a pipeline. So what you can do is you click on pipeline, and you can click on make Python scoring pipeline also as off, and also make pipeline visualization as off. So I'm just applying the settings because, yeah, so that we can finish our experiment faster. Yeah. But even if you don't apply these settings, still your experiment will continue. It will just take a little bit more time. Okay, so after I applied these settings, then I'll quickly launch experiment. So Traveler CI has given me these default settings of accuracy 7, time 2, interpretability 8, and it has also given me a scorer of log loss. But I will explain what these settings mean. But before that, what we do is let's launch the experiment. Yeah. So after we have launched the experiment, so Travelers AI is trying to firstly ingest the trained data and try to understand the schema of the data. Then it creates the validation splits for the data set. Here it is giving us some notification that we are using the NLP transformer pipeline. So for NLP transformer pipeline, what kind of models it is going to use. So it has told us that it is already enabled PyTorch BERT models, which will be used in this pipeline. So the instance that we are using within Aquarium is a P2X large instance, which has GPU. So for the experiment, you are going to use GPU as well, and you can see the GPU usage at this bottom right corner. Yeah. So this will take a little bit time to like load the data and load the models and create pipelines and yeah, start the process. Um, but yeah, while this is happening, what we can do is we can take a look at those settings which Travelers AI provides. So for that, what I can do is I can go to experiments again, and what I can do is I can so this experiment, you can see that it is running, and it is status is 0% because it is still trying to assess how much time it is going to take. What I can do is I can create a new experiment from the same setting. So I can click on these three dots at the right of the experiment tab, and I can create a new experiment with the same setting. Just ignore this and click not now. Yeah. So what it's doing is creating a lineage. So it has created a child of that particular experiment. So I've just opened this link so that I can explain what are the different settings in Travelers AI. So Travelers AI actually uses advanced feature engineering and model assembling techniques. So there's a lot of feature engineering happening, a lot of feature selection happening, and it creates a lot of comprehensive models and searches through those models, like which model is going to give us the best results. So this sort of model selection also happening, and for those models we have hyperparameter optimization also happening. So to select the best model and best features and best hyperparameters, what WLSCI does is it brings this whole process through a genetic evolution process. And via genetic evolution, the different models, different features, and yeah, and the number of iterations it goes through, that happens via genetic evolution process, which I will show you later in our original experiment. So what this accuracy and time and interpretability setting do is these settings, they control the evolution of these models, so that we are able to get the most optimal models for our experiment. So by accuracy setting, we can increase the accuracy setting to tell that we want more accurate models. So when you increase the accuracy setting, then it looks through more complex kind of features, and the final pipeline is also a kind of ensemble of the different models, so that the accuracy is higher. And this time knob it tells us like how much time we want to give to Travelers AI to finish this experiment. So it controls the number of iterations that Travelers AI is going to go through for this particular genetic evolution process. So we can so currently there are 42 iterations, but we can like reduce this, and we can see that the number of iterations has reduced to 33 iterations. Then Travelers AI applies extensive explainability techniques for understanding our final models, but still you can try to create more explainable models by increasing the interpretability settings, um, so that the feature space and the model space it looks through is more simple models. And or if you are okay with less interpretable models, then you can just yeah, keep it as low setting. And then, as I mentioned, the Travelers AI automatically identifies that this is a like a classification experiment or regression experiment. So it gives you a by default some scorer that you can use to optimize your models. but you can choose a different scorer as well, such as AUC or macro AUC, etc. So these are the models, and this is how you can control your experiment. Yeah. So as I mentioned, like since we are working with, so these are the default settings. But if you are more experienced data scientist and you want to control your experiments more furthermore, then you can click on expert settings. So within expert settings, you have settings available for controlling the experiment, controlling the model, controlling the features, the feature evolution. Then if you're working with time series data, then you can pick different parameters for time series modeling. But in this case, we are working with NLP data. So that's why I clicked on these NLP settings to tweak my experiment, where I specified. So there are different NLP settings available. Like for example, if you want to use convolution neural network models, if you want to use bi-GRU models, or you want to use character-based CNN models, which Shivam introduced earlier in this talk. But in this experiment, what we want to use is we want to use multilingual NLP models, which are PyTorch based. So that's why I went into this expert setting and I clicked on this select values, and I tried to select this BERT based multilingual model and XLM Roberta based model. Yeah. And in the experiment also, I tried to control the experiment, and I tried to use the NLP transformer pipeline for my experimentation. So yeah, so these are the advanced settings. If you have time, you can play around with these. If you can also try to bring in your time series data and image data, etc. as well. Yeah, but so these are expert settings, and these are the default settings that you can use for creating your experiment and solving your use case. So, but yeah, I don't want to launch another experiment here. Let's go and take a look at the experiment that we had launched earlier. So I click on experiment and I try to see, yeah. Okay, it's taking a bit time. It should be launching soon. Yeah. So meanwhile, while it is launching, what I can do is I can also show you another feature. Like if you, for example, I can again try to create another experiment from the same settings. And actually in the expert settings, I can show you another feature, which is uploading like custom recipes. So this features uploading custom recipe actually is also called like bring your own recipe framework within driverless AI. So for example, if you for NLP kind of experiments, for example, you want to use your own models, or you found some other Hugging Face model that you think will work better for your data set. So for example, if I'm working only with the Chinese data, and so in that case, if my data set is only Chinese data set, and then I may not want to use a multilingual model, and I may want to use a dedicated like a Chinese BERT model, because this dedicated Chinese BERT model will in general perform better compared to multilingual models that has been observed in different papers in the literature. So what you can do is you can try to upload your custom recipes. Um, so actually, I already have a recipe for Chinese bird, so maybe I'll show you how it works. So after you click on, so you can upload a recipe from a particular URL, like for example, from your GitHub URL, or you can upload from your local laptop or workstation as well. Yeah, so for this particular use case, I can try to upload uh, from my local laptop. So I have created a recipe for Chinese bird, and let me show you what this recipe looks like. Yeah. So to upload your own models, for example, here I'm trying to upload a bird-based Chinese model from Hugging Face. So we have created a template for bringing in Hugging Face models, and you can use this template. And I will share the link also for how do you create this template to bring in your custom Hugging Face models. So here I have included like a bird Chinese model, so that if my data set has Chinese language data, then I may want to use this bird-based Chinese model. not a multilingual model. Yeah. So after I have uploaded the BERT model, then what I will do is I'll click on recipe, and I'll try to see if my model has been uploaded properly or not. So you can see that the Chinese BERT model that I uploaded is now available as a transformer for my experiment. So that's the idea. So if you have your own models, you have your domain-specific models, domain-specific BERT models, or you have some other Hugging Face favorite models, then you can bring those in within this AutoML process as well. Okay, now let's go back to experiment. Oops, somehow it is taking longer at the moment. Okay, so while this is running, what I can show you is a finished experiment that I had tested earlier. So here I had created a similar experiment with the similar data set. So if I click on this, then I can show you a completed experiment here. So this is a completed experiment. So hopefully we'll see the experiment evolution process for our original experiment soon. But this is how a completed experiment looks like. And so as I told you earlier that driverless AI goes through a genetic evolution process to select the best models and the best features. So for our use case, we had specified that we want like the multilingual BERT models and XLM Roberta model as our feature generation models. So actually it is looking through those models as the feature generation models, and on top of that it's applying like a decision tree or XGBoost or LightGBM kind of models and see which model works the best. So for this experiment I tried to minimize the log loss, classification loss, and yeah, you can see that in the experiment, driverless AI is going through this genetic evolution process, is experiment through different combinations of models and different combinations of features. So here it's trying to work with a LightGBM model with multilingual BERT and Roberta base. Then here it is using XGBoost model. And then finally, after the genetic evolution process has finished, then the best model is actually XGBoost model with 12 features, and these are the 12 features which are the different features created by driverless AI based on the multilingual BERT model and XLM Roberta model. And for this particular model, actually I kept the time setting as very low because I wanted to finish the experiment faster, but we can increase the time setting to higher if you want more and more accuracy as well. So for this experiment, we can see the summary of the experiment here, but let's take a look at that later. Firstly, we can take a look at the average ROC over the experiment, which was 0.84, and we can also take a look at the confusion metrics for the different labels. So we had three labels: contradiction, entailment, and neutral, and you can see that there is a significant error here for each of the label because actually we tried to finish the experiment quite fast and the time setting was pretty low. But still, our performance is actually not bad. It's still pretty good. And same thing for the test set as well. So driverless AI gives you the performance for the validation set as well as the test set. So you can take a look at the ROC, you can take a look at the precision recall curve, then lift curve and gain curve, etc. And then you can take a look at the confusion metrics for this multi-class classification model. So another thing, so this is a finished experiment. So after the experiment has finished, I can see that I have different options available. So either I can download the predictions on the training set and the test set. I can download the deployable artifacts, which can be Python scoring pipelines, or it can be Mojo scoring pipelines. Or I can also visualize the scoring pipeline, which is the final pipeline which gave us the best results. So yeah, so here you can see this is the pipeline which gave us the best results, which is on high level. It is a combination of it's a stacked ensemble of three XGBoost models. And if I click on one particular XGBoost model, then it is using BERT transformer models and logistic regression. So it is doing extensive feature engineering underneath to give us the best model. So after the experiment is finished, what you can do is also you can download the AutoDoc. So AutoDoc so Travel SAI provides you the documentation of the whole process. So you can download the AutoDoc to look at the whole experiment after the experiment has finished. So it gives you what actually happened in the experiment. So if you can see the feature transformations that we use by Travel SAI are the BERT multilingual models. Okay, hopefully our experiment has started. Oops, somehow it is taking longer. Okay, what I can do is we can, so while this is running, hopefully for other people, you were able to start the experiment. I'm still not able to capture the modeling backend. That's the issue. So can I check if other people are able to start the experiment, if someone is able to respond on the chat? Or what I can do is I can try to. All right, let's try my luck again. But hopefully for others, they were able to start some experiment. So Lawrence, can you see on the chat if you others are able to start?
Just give me a second.
Anyone has responded?
Yes, I think Mace, I think he says that there's actually 1% complete
Okay, okay.
earlier on. Yeah. And then maybe while we're waiting for the demo to load, right? Maybe there's this one question. Maybe Vishal, you can try to answer first.
Yeah, sure.
We have Yin Yang. So the various embedding methods you have elaborated with transformer, etc., provide contextual embedding at a word level. What do you do to combine them in dot level embedding before classification?
Yeah. So if you are working with document kind of data set, where you are where the data set, I mean the text is quite long, and then there are other techniques actually to work with that kind of data set. So you can actually summarize the data set. So uh, if I can show you something here. So as I mentioned that in the expert settings, we can add additional recipes. So, so we have some recipes actually for summarizing the data set. Yep. So this is the text summarization recipe that you can use. So actually, you can create recipes for data Travel SCI very easily. You just need to follow certain base class template. So yeah, this is one recipe that we have created which you can use to like firstly summarize the document and then create the predictions for the document. Or what you can do is using the same recipes, you can bring some of the latest models like long former models or big word models, which are also able to do document level classification. Yeah, so that is one idea. Or other idea is that if you simply want to use the BERT models which are available here, then what you can do is instead of creating like document level embeddings, what you can do is if your data set here if your data set here is a long paragraph or long document, then you may want to first tokenize it into sentences and create like the predictions for those sentences. And then after you have predictions, then you just combine them later after you obtain the predictions from the Travel SAI as an average, yeah, or yeah, mode, anything else. Hopefully that answered the question. Yin Yang. Thanks for the question.
So, are your NLP models explainer tools providing the most important features at word or character level, or does it work at the level of embedding dimensions?
Yes. So actually, our explainers they do work for NLP models. Um, so let me see if I have an explainer. Uh, but meanwhile, while I try to show that explainer, to answer the question, our explainers actually they work at word level, token level, and we don't provide explanations at character level or actually at the embedding level because for real like business use cases, when we are trying to showcase our model results to business, then they want to see how the explanations look at the word level. Yeah, like which word is contributing to the particular decision, which will be like a sentiment or some other decision. Yeah. Maybe I'll try to open one page here. Yes. So there's a documentation for Travel SAI. Um, so so you can look at the interpretability settings that Travel SAI uses. So if you can go to NLP. Yes. So for NLP experiments, we use techniques like NLP loco or NLP partial dependence plots, NLP vectorizers or NLP tokenizers. So these are able to, for any NLP experiment, they are able to provide the explanation at actually the token level, not at the character level or embedding level, because those explanations are actually not very understandable by business. But we do have advanced like explanations as well. So Shivam may want to add something here.
I think, Vishal, what you shared is pretty much sums up what we have incorporated in NLP explainability.
Hmm.
We do reverse engineer a lot of embedding spaced output to go to the word level or the token level understanding to make sure the final outcome in terms of explainability that we give is basically um, are the which words have the most important impact, have the most significant while say making a classification or maybe a regression.
Yeah. Thanks, Shivam. All right. So luckily, yeah, my experiment has started. I try to create a new experiment with very low settings here. Yeah. So so this is, yeah, here the model actually is going through the genetic evolution process very fast. Yeah, it's trying to train different models and it's trying to use boost model on top of that. Yeah, evolution process very fast. And here you can see the GPU usage that AAI is doing for training these models. And on the fly, we can see at the current state of the experiment, what is the confusion metrics and what is the ROC values, what is the precision recall values. So hopefully most of you are able to start this experiment and you should be able to see the results like within 30 minutes, I think, after starting the experiment. Um, but this experiment I started with very low settings, so it will finish very, very fast. All right, so it is going to create the final pipeline. Any other questions that we are seeing, Lawrence?
No. So I think Shiva has answered May's question. Yeah.
Okay,
So yeah. So audience, if you have any questions, feel free to ask. So we can actually put a question on the, you can actually put the questions on the comment section.
so hopefully this talk was able to give you an overview of like how within Travel AI we try to cover all the bases. Like we try to cover TF-IDF, word vectors, yeah, count vectorizers, and then advanced BERT models as well. And we bring features from all these kind of approaches into our AutoML process, so that the final model actually covers all the bases and it is actually the best performing model for your particular use case.
Also, I
And
would
that,
like to share the platform that Vishal demonstrated today will be accessible to you anytime. You can always log in with your account, and you can start a new lab. The lab will be applicable for 2 hours, so it will self-destruct after the 2 hours. So, if, in case you want to do some AutoML experiments, not just limited to NLP, but say image, computer vision, time series, you can always use these labs later on as well.
yes. Okay, so hopefully everyone is able to run the experiments, and so I've extended the lab for like 1 or 2 more hours, so that you are able to like view your experiment, see the results, and then you may want to bring in your own data set also to try on the NLP pipelines, or you may want to try some time series or computer vision kind of experiments as well. Yeah, so please feel free to use that platform.
Hello, hi. Thanks for sharing, this very impressive platform. So personally, yeah, I can see how this is really a very impressive platform. So I actually, while we wait for more questions to stream in, right, I do
Mhm.
have a question that maybe we can discuss. So I think with the rise of auto ML in general, maybe not just for this one, I'm looking is a very specific use case on ML on NLP, right? So there are
Mhm.
also other auto ML on maybe more structured data sets.
Mhm.
So it seems like the focus of data scientists should be shifting away from tuning the models themselves, right? Because essentially it is doing a brute force of a lot of different combinations of transformers, a lot of different combinations of embeddings, and then at the end, it's just optimizing for the metric that you want.
Mhm.
So where do you think, in future for data scientists, the focus of their work should shift towards?
Yeah, that's a very good question. So actually, yeah. So what AutoML is trying to do is it is actually trying to like replace all the like the statistical or data-driven feature engineering and experiments through law of models, etc. So that's where it tries to replace like the different experimentations that the data scientist has to go through. So the if the data scientist is like doing like a months, taking like months of time for doing feature engineering and for trying out different models. So that time can be reduced to like days, like from months to days. So that's where the AutoML is creating value for data scientists. But still, you need data scientists. Uh, they are the experts, especially if you are working for, uh, for your company, for your corporate. Then you most of the time you need some domain specific expertise, and you need to bring in those domain specific expertise into your AutoML process. So that's where the role of data scientists is becoming more and more important. So they should be able to solve the business-driven use cases. They should be able to formulate the data science machine learning problem when they are working with business. And the other task of creating features and building models that can be taken care of by AutoML. So it's still the role of data scientist is very important. Yeah.
Yeah, just to
So
add on what Vishal shared, so scientist still is a very, very important persona for any data science use case. What AutoML is driving is automating the routine task or the mundane task of a data scientist. But still, when there is a, let's say, very specific tailorization to be done, customization to be done, depending upon the industry, depending upon the use case, data scientists need to tweak the AutoML process and really need to solve the use case according to the need. And sometimes the creative feature engineering ideas will be driven by data scientists itself, but all the routine process can be automated, so they can really increase their productivity with this type of platforms.
Yeah, okay, I agree.
yes.
So I noticed in H2O there's also deployment options. So maybe do you want to share so we know that all this um, basically evaluation of the model are done on an offline basis. So how do we detect issues in deployment in real world, right? For example, model drift and when the real world data starts to change from the training data set.
Right. So now we are talking about the end-to-end machine learning, the whole process, the life cycle. So what we discussed today was like building models and specifically NLP models. But if you want to like deploy these models, then we have another product which ties in very closely with driverless AI, which is called H2ML Ops. Using H2ML Ops, you can deploy these models into your production environment or your UAT environment, and so you can deploy them in like a A/B testing format or A/B testing mode or like as a champion challenger mode. And within that H2ML Ops, you can also monitor those models and see if the model performance is drifting or the underlying feature distribution is drifting. And if there is, you detect this kind of drift, then you can create alerts and that this model needs to be retrained. Or you can also create a pipeline where you can auto retrain the models if this drift is detected. So this is taken care of by MLOps. So you can so if you're interested in the whole suite of products, then yeah, you can actually go to h2.ai and you can see the different suite of products that we have. Which so everything, the whole machine learning lifecycle is covered by H2 AI Hybrid Cloud, which covers the make part, which is the driverless AI. Then operate is covered by the ML ops, and then you can also build products or apps on top of these built models, which really helps in bringing the AI to enterprise wide. So this is the ML ops platform. Which allows you to create a model factory and deploy models and also monitor those models in production.
Got it. Okay. So meanwhile, we have another question from Mace. So the question is not regarding NLP, but whether or not if you have any experience on satellite or remote sensing data sets and any resources.
Definitely. So we work because we work with many government use cases as well, and sometimes we work on meteorology kind of use cases. So we work with satellite data, and for satellite data, we use our computer vision suite of models. Um, So for computer visions, again, we use those models such as like the efficient net or exception models. Uh, yeah. In addition to those ImageNet kind of models to deal with satellite data. So if you are, please go ahead. Yeah, I was saying that if you are, sorry to interrupt. Yeah, so if you are curious about that, please feel free to contact us as well, and yeah, we can discuss your use case and how you can use H2O for solving those use cases, or we can have an open discussion as well. Sorry, Ivan.
Hopefully that answers the question. So yeah, I do actually have another question. So I'm looking at variable importance from the H2O driverless platform, right? Mm-hmm. So as you mentioned, so this one actually does variable importance at the model level. So there was another question on like the variable importance at the word embedding level itself to understand what word is actually driving the decision for it. So maybe for computer vision, how do you actually interpret variable importance? Because it's going to be, yeah.
Yeah, so that's also a very good question. Sorry, maybe what I can. So for computer vision, what we use techniques like heat, gradient maps to like understand like which area of that particular image is actually contributing to that particular decision. So what I can show is maybe one particular example here. So this was one use case which we did for one of our manufacturing customer. So the idea was to detect a defect in wafer, the silicon wafers, and when we did this experiment, so we used the images and on after we train the models, then we use grad cam visualizations to identify like the area of those images which are contributing to a particular decision. For example, what is the particular, so this use case was like what kind of defect is there in the particular wafer image, and yeah, that kind of visualizations allow us to highlight the area of that image which is contributing to that particular decision. So yeah.
So I
Thank you.
think we would, yeah, thanks for sharing this. This is a very impressive end-to-end platform. So I think that's all the questions that we have. Is the lab actually concluded, or are there any other features that you would like to showcase before we conclude the sharing session?
No, I think that's all I wanted to share to actually see, I mean, how you can use multilingual NLP models. So that's what actually wanted to focus on, that for multilingual data, we should use multilingual models instead of like using translation kind of techniques, which adds to the headache of the whole NLP pipeline. So, so that's the best practice, and you can use multilingual models for your use cases, like such as multilingual BERT or XLM Roberta, and now there are more advanced multilingual models, yeah, which you can start using. And yeah, using H2O's AutoML, yeah, you can use them very easily.
Okay, got it.